Hello, I'm Dr. Ronald W. Satz, founder and chair of the International Society of Unified Science. This is my paper, Space-Time Dimensions and Natural Unit Values of Physical Quantities. Abstract. This paper presents the derivation of the space-time dimensions and the natural unit values of physical quantities in the reciprocal system. Factors include space S and time t only, with auxiliary units of cycles, revolutions, radians, and steradians. The appropriate time-space region, macroscopic value, and/or time region, microscopic value of space is used in the various mechanical, electrical, magnetic, thermal, and photonic units. The dimensional system of the reciprocal system is unique. No previous system compares. Introduction and Literature Survey. Many dimensional systems exist. Reference 3, pages 146 through 166, and pages 386 to 418, provides the most detailed treatment of these. Included are the dynamical system, the gravitational system, the astrophysical system, the electrophysical system, the electrotechnical system, the definitive system, the practical system, the energetical system, the electrostatic system, the electromagnetic system, the thermophysical system, the thermotechnical system, the Gaussian or CGS system, and the MKS or SI system. None of these systems is natural in the sense of being based on the fundamental properties of space and time. Doobie Larson, the originator of the reciprocal system theory, was the first theoretician to ground the dimensional system on the true physical realities of space and time. We present his new dimensional system in reference 1, first edition, pages 25 through 27, 73 through 83, 210 to 211, and reference 1, second edition, pages 157 through 171, and reference 2, pages 102 to 111, pages 183 to 186, and pages 219 to 229. This paper extends the work to the calculation of the space-time units, the CGS units, and the SI units of all mechanical, electrical, magnetic, thermal, and photonic physical quantities for the time-space region and/or the time region as appropriate. A convenient table summarizing the results is presented at the end. References 4, 5, 6, and 7 provide conversion factors for going to and from the CGS and SI systems. Most of the factors provided are given to 3 decimal places only. For more precise work, one would have to use the conversion factors in reference 5, pages 1-23 to 1-32, which are expressed to 5 or 6 decimal places. James Clerk Maxwell, in reference A, volume 2, page 267, gives a table of electric and magnetic dimensions, which are quite bizarre, yet this physicist is considered to be the greatest of the 19th century. Nonetheless, he did provide one very useful suggestion in volume 1, page 5, quote, "If we adopt the units of length and time derived from the vibrations of light, then the unit of velocity is the velocity of light." Unfortunately, Maxwell didn't follow up on his own suggestion, but Larson did. The space-time dimensions given in this paper apply to our half of the universe, the material sector. The space-time dimensions of the other half of the universe, the cosmic sector, are just the inverse, with space and time interchanged. Next in this paper is the nomenclature, and I'm not going to read through these symbols here. We'll introduce them as we go along in this paper. But I will go through the notes here. Note 1, a black square in the upper right of an equation means that the equation is disabled from running in MathCAD. This is done because not all of the variables in the equation have as yet been given numeric values at that point in the program. Note 2, we've attempted to use the same symbols here as in other papers and books on the reciprocal system, but given the large number of symbols necessary, there will be some differences. Please consult the nomenclature of each individual paper for the symbols used in that paper. Also, in a few cases, duplicate symbols for different properties have been used, but no ambiguity should result. Always consider the context. Note 3, in the following equations, the subscript u and the variables will apply to the natural space-time units, stated in centimeters per second and auxiliary units, if any. For CGS values, the subscript CGS will be used, and for SI values, the subscript SI will be used. If only centimeter per second and auxiliary units are used, the CGS subscript will usually be left off. The subscript T means the time region value. And note 4, the calculated values of the natural units are given to 6 decimal places. Because there is some uncertainty in the speed of light and the Rydberg frequency of H1, there is uncertainty in the 5th and 6th decimal place. For most scientific and engineering work, 4 decimal places should suffice. The slight differences in the values given in the various books and papers of the reciprocal system are de minimis. First of all, discuss mechanical units, space-time and translation speed. In pure natural units, the reciprocal system time-space region equation for velocity is, of course, natural unit speed equals natural unit space divided by natural unit time, or 1 equals 1 divided by 1. All natural physical units in the reciprocal system are 1, of course. To get anything useful out of the theory, we must identify the corresponding physical quantities expressed in conventional units, such as in CGS or SI. Obviously, the speed of light is the natural unit speed of the universe, and so we have c equals 1 over 1. In many reciprocal system books and papers, we use this CGS value for c, 2.997925 times 10 to the 10th centimeters per second. A physics chemistry establishment, reference 5, page 1-1, has recently fixed the value at 2.99792458 times 10 to the 10th centimeters per second. And reference 1, second edition, page 160, Larson used this value, 2.997930 times 10 to the 10th centimeters per second. Depending on which particular value one chooses, the values of the resultant natural unit of space and natural unit of time expressed in conventional units will be slightly different. In order to get the natural unit of time, we use the Rydberg frequency of h1. This is the natural unit frequency. In most reciprocal system books and papers, we use this value for r with auxiliary unit cycles. r equals 3.288057 times 10 to the 15th cycles per second. Unfortunately, the physics chemistry establishment has switched to the, quote, infinite mass definition for this constant, rather than that based on the unit mass of h1. We think this is an error, and so we will continue to use the above value. In the unit linear vibration of the Rydberg photon, there are 2 units of space and 2 units of time, 1 of each for up and 1 of each for down. The natural unit of time can therefore be calculated by taking 1/2 the inverse of r. So we get t sub u equals 1.520655 times 10 to the minus 16th second. With c sub u and t sub u known, s sub u can be found, and that's 4.558809 times 10 to the minus 6 centimeters. But this value is a bit lower than what we have commonly used in the reciprocal system, which is 4.558816 times 10 to the minus 6 centimeters. This implies that the, quote, true speed of light is 2.997929 times 10 to the 10th centimeters per second. As you can see, there's some uncertainty in the last 2 digits. For our purposes here, and to stay consistent with previous work, we will stick with using the value of s sub u from equation 4b and the value of c sub u from equation 1g. All of the values of c round to the value given by Larson regardless. In the table below, the value from equation 1d will be put below the value from equation 1g as an alternate. The SI values for the natural unit of space are 4.558816 times 10 to the 8th meters, and that gives the speed of light as being 2.997929 times 10 to the 8th meters per second. The above values are for all of the macroscopic time-space region. For the microscopic time region values, we must divide by the interregional ratio, 156.444. Please see reference 1, second edition, page 154 and page 162 for the derivation of this constant. So that gives the time region natural unit of space calculated to be 2.914017 times 10 to the minus 8th centimeters, or 10 to the minus 10th meters. A specialized length unit is used for atomic diameter. In the reciprocal system, the atom is the same size as the supposed nucleus of the conventional atomic theory, using the reciprocal system alpha particle scattering theory at a reflection angle of 156 degrees, which is the standard angle used. The natural unit value of atomic diameter can be shown to be 3.359 times 10 to the minus 13 centimeters, or 10 to the minus 15 meters. And derivation of this is given in appendix 1, which we'll get to later. The time region unit velocity is obviously then 1.916291 times 10 to the 8th centimeters per second, or 10 to the 6 meters per second. Now from here on out, I will not always verbalize the numerical values. You can see them on the screen. And of course you can download a free copy of this paper from transpower.wordpress.com. I'll just point out the units involved in each case. So here you see the time-space region values of area followed by the time region values of area, and then the time-space region values of the natural unit of volume, and then the time region values for volume. Rotational speed and frequency. The unit rotational speeds are the same as the unit translational speeds, but the natural unit rotational vibration frequency is different from the natural unit linear vibration frequency. Obviously, we have to use pi here, so we get 2.093242 times 10 to the 15th rev per second, or in terms of radians, 1.315223 times 10 to the 16th rev per second. Acceleration. And you can see here just by definition is S sub u divided by t sub u squared. I give you the natural values, time space, and then time region values. And then in terms of radians, we have 8.649055 times 10 to the 31 rad per second squared. Now mass is interesting. Mass is not fundamental in the reciprocal system. It's a space-time quantity, so that's what makes the reciprocal system unique. We reduce everything down to space-time. In this case, mass is tu cubed over su cubed, and that comes out to being 3.711383 times 10 to the minus 32nd second cubed divided by centimeter cubed. There's no time region value here. Unit atomic mass 1 AMU, which by the way is not the same as U, can be identified as the conventional equivalent. Therefore, we get the natural unit of mass expressed in conventional terms as 1.659790 times 10 to the minus 24 grams, or 10 to the minus 27 kilograms. Density is just mass divided by volume, so you can see these sides by inspection. Specific volume is simply the inverse of density. Again, I have the time-space region values and the time region values. Linear momentum is mass times velocity. And again, you can see time-space region values and the time region values here. Rotational momentum is mass times velocity times a distance, obviously. So you can see here the natural value and then the time-space region value and the time region values. Force is mass times acceleration, or natural units t sub u divided by s sub u squared. So here we have values in second per centimeter squared, and then also in dynes and newtons for both the time-space region and the time region. The mechanical time region values are appropriate to use for the nanotechnology machines because they act inside of unit space. But what that is, that. It's a live transmission here, so here we go. So, mechanical time region values are appropriate to use for nanotechnology machines, but whereas gravitational force may usually be neglected for time-space calculations. Reverse gravitational and progression forces must usually be considered when doing time region calculations. See Appendix 2. So we'll cover that later. Pressure is force divided by area. So here we have the natural value, then we have the time-space region value. This is the natural unit of pressure for ideal gases. Because of the interatomic attraction in solids, liquids, and vapors, and well, gases, the pressure is different for these states of matter. For solids, we use the time region expression for force, but we keep the time-space region expression for area because pressure is a macroscopic property. Curious but true. So in this case, we have 1.00641 times 10 to the 11th dynes per centimeter squared, or 10 to the 10th newtons per meter squared. For liquids which have 2/3 of the cohesion of solids, we must multiply the solid volume by 2/3 and divide by another interregional ratio. So here we have, for liquids, it's 9.589834 seconds per centimeter to the 4th power, which translates to 4.288727 times 10 to the 8th dynes per centimeter squared, or 10 to the 7th newtons per meter squared. For vapors which have 1/3 the cohesion of solids, we must multiply the solid value by 1/3 and divide by still another. I should say it's just 1/3 instead of 2/3 from the above expression. So there's the pressure for vapors, 1.370687 times 10 to the 6th dynes per centimeter squared, or 10 to the 4th newtons per meter squared. Okay, now back to something simpler. We get to torque, which is simply force times distance. You can see the second per centimeter value there, dynes, centimeter, newton, meters for both the time, space, and time agent values. Moment of inertia. Moment of inertia is defined as the mass times distance squared. Nothing complicated here. Here we have dynamic and kinematic viscosity. These are macroscopic properties of liquids, and so only the time-space region values apply. So IDU is defined as T sub u squared divided by S sub u to the 4th power. So there we get the natural value, the Poisson value, and the Newton second squared value. But we commonly use centipoise instead of poise, so the natural unit of value for dynamic viscosity is 2.394255 times 10 to the minus 1 centipoise. Kinematic viscosity is dynamic viscosity divided by density. You can see the values there. Centistokes and Stokes. Surface tension. That's 1/3 the natural unit of pressure times the natural unit of distance divided by the cubed interregional ratio. It is a macroscopic one-dimensional property only, and you can see the calculations here. Energy. It's the inverse of velocity, or force times distance. So you can see second per centimeter value there, it's joules value for both the time-space region and the time region. Here's Einstein's famous equation. The natural unit value of V is 3.335,636 times 10 to the minus 11 seconds per centimeter. So let's do the second per centimeter values of MU times CU squared. And guess what? We get the same result. Amazing, it works. Incidentally, that verifies the space-time dimensions of mass. Power is energy per unit time. Pretty obvious here, joules per second, for example. Both the time, space, and time region values. Okay, now we come to electrical units. We give both the time, space, region, time region values here as appropriate. As appropriate, that's important to understand. Electric quantity. Now here's where we differ from conventional theory. Electric quantity is simply one natural unit of space, whether using the time-space region value or the time region value. From Larson, in reference to page 21, quote, unit of space in the region inside unit distance, the time region as we call it, is inherently just as large as unit of space in the region outside unit distance, but is reduced by the interregional ratio 156.44 for reasons previously explained. We cannot legitimately regard this quantity as something less than a full unit, since as we saw in line 1, it has the same status in the time region that the full-size natural unit of space has in the region outside unit space. The logical way of handling the situation appears to be to take the same, there are two different natural units of distance when dimension of space, a simple unit and a compound unit that apply to different circumstances. So, time-space values will apply to quantities which are not per distance or per area or per volume. Those which are per distance or per area per volume can have either time, space, or time region values. So that's key to understanding electric units here. In this case, for the quantity, we're using the time-space region value, 4.558816 centimeters. which comes out to be 1.602062 times 10 minus 19 coulombs. Like conventional theory, the reciprocal system distinguishes between electric quantity and electric charge. They have different dimensions, hence the subscript. So this is important to emphasize. The unit of quantity in conventional theory is the charge, whereas it's a space unit in the reciprocal system. Electric current. Ordinary electric current is the flow of massless, chargeless electrons. So obviously, SU divided by TU, in this case, comes out to being 1.053534 times 10 minus 3 amps. So you can see that actually for currents greater than a milliamp, approximately, electrons, in terms of space per time, are moving faster than the speed of light through matter, which, by the way, is a time structure. Electric current density is electric current per unit area. Here we have both time-space region values and time region values. Electric charge or flux. Now, these are the units of charge, and here we agree that the natural unit of charge is that on the electron or the proton. That's 1.602062 times 10 minus 19 coulombs. And notice that we use the subscript charge here to distinguish the ESU and coulomb from quantity. Electric dipole moment is electric charge times distance. Electric charge volume density is charge per unit volume. Again, we have time-space region values and time region values here. Electric energy. It's the same as the natural unit of mechanical energy, it has to be, which is 1.491750 times 10 minus 10 joules. Electric power. Turns out it's 9.809916 times 10 to the 5th joules per second. Electric voltage. T sub u over S sub u squared. There's only the time-space region values here for this quantity. Pretty high voltage, 9.311435 times 10 to the 8th volts. It's a natural unit. Electric field intensity is electric voltage per unit distance. Electric flux density is electric charge per unit area. Electric resistance is electric voltage divided by electric current. Note that it's also equal to mass per unit time. So this is T sub u cubed divided by S sub u cubed divided by T sub u, and we end up with 8.83824 times 10 to the 11th ohms, which is pretty high. But obviously, using the natural unit of resistance times the square of the natural unit of current times the natural unit of time should equal the natural unit of energy, and of course it does. Electric conductance is the inverse of electric resistance. Electric resistivity is resistance times distance. Crystal unit cell parameters determine this value, and so the time region unit of space must be used. So in this case, we have to use the time region values, interestingly enough. Electric conductivity is the inverse of electric resistivity, of course. We use moles per meter. Okay, electric permittivity of free space, that's simply S sub u squared divided by T sub u. And by definition, CGS, it's 1. And by definition, SI is 8.85418 times 10 minus 12 farad per meter. Electric susceptibility, so by definition, the relativity permittivity of free space is 1. So the electric susceptibility is 1 minus epsilon naught r. So the natural value of susceptibility would, of course, be 0, as you would expect. The CGS and SI units are the same, which is 0. Electric capacitance. Only the time-space region value applies because unit capacitance is equal to the unit of time divided by the unit of resistance. So we get 6.23053 times 10 to the centimeter cubed per second. Now notice that that is SU cubed over T, so it's the dimensions of a source or a sink, which makes sense. A capacitor is a source or a sink for electrons. To get the corresponding CGS and SI units, we note that the time constant RC with an RC-DC circuit must be equal to unit time. So we get this, memorizes for staff farads and farads. 1.70552 times 10 to the minus 28 farads. NSI. And I have a couple of checks here. The various checkout in terms of energy. Incidentally, this is a modification from what was originally thought to be the case in 1959, and in subsequent of Larson's books, the capacitance was set equal to space only, rather than space cubed divided by T. So this is a change that's been made, but it's one of the very, very few changes that we've had to make over the decades. By definition, electric displacement is electric quantity per unit area. By definition, electric polarization is electric displacement minus the permittivity of free space times the electric field intensity. Therefore, the natural units are the same as those for electric displacement, which you can see here. Unlike conventional theory, the ESU and coulombs here are electric quantities, not electric charges. Ordinary capacitors store massless chargeless electrons, not charged electrons. So it's a major difference there between the reciprocal system and conventional theory. Okay, now we come to magnetic units. We'll start this and then we'll end part one. Magnetic quantities, which are analogous to electric quantities, have the dimensions of the corresponding electric quantities multiplied by 2 or less. That makes for a major simplification in physical theory. Magnetic charge are flexible. Magnetic charges exist in a reciprocal system, unlike in quantum mechanics. And here we have it. A natural unit of magnetic charge is 4.802863 times 10 to the minus 18th electron. There it is. And here's the Larson magneton. This is to a reciprocal system, but the Bohr magneton is to quantum mechanics. And you can see the calculation here. It comes out to 9.317503 times 10 to the minus 37 microliters. Magnetic dipole moment is magnetic charge times distance. No surprise here. Magnetic moment from current. Again, the units are centimeter cubed over second, which is kind of interesting. Same as for capacitance. Magnetic flux density is magnetic charge per unit area. This is a very important quantity. Notice its symbol B, standard in the literature. So in the time-space region, it's 2.31097 times 10 minus 3 Webers per meter squared. And in the time region, it's 5.65 times 10 to the 1 Weber per meter squared. Magnetic permeability is given here. Magnetic susceptibility is, by definition, it's 1 minus mu sub 0 r. So chi mu sub u is 0. Now, please remember that the chi mu sub CGS is equal to chi mu sub SI divided by 4 pi. Just keep that in mind. Magnetic field intensity is here. That's defined as magnetic flux density divided by magnetic permeability. We generally prefer to use external magnetic flux density divided by mu0 rather than this. So we tend not to use magnetic field intensity in the reciprocal system. Magnetomotive force and magnetic vector potential. You can see the values here. So we have the correct values. It turns out so the conventional units are wrong. The correct values for the magnetomotive force are EMU per centimeter Weber per meter, not amp terms. It's kind of a bizarre unit in conventional physics. If using magnetic vector potential instead of magnetomotive force, substitute A sub p for F sub m mu in the above equations. And for the time region, look at these values. And we'll stop here. That concludes part 1. We'll continue with this in part 2.